therefore I think I need to do a bit on the conclusion, I think. Alright, as I see that there's certain part that you may want to know is when you design a microcontrollers to drive a simple load, alright, such that because microcontroller itself has not enough powers, so you need a transistors or MOSFET to actually help you to take in power from other sources. So the bipolars and the MOSFET is something like a switch, so that if you supply enough small current, you can actually open up the gate. If you still remember the bipolar, whatever, I don't go into details, but at least you get to know this other stuff. And just take note that whenever you design something for loads that are large, you may be careful of the inductive loads, or because you actually cause a back EMF that will actually cause your system or disrupt your system, or destroy your system, things like that. Alright, and nonetheless, you need to take note of the when you design your motor. Alright, you can design your motor in terms of a pulse width modulation, something like onning or offing your LED light, delay everything. Alright, you can run it in using your software or whatever to actually somewhat control the timing of the pulse width. Alright, the pulse width, as I show you, these are all the pulse width to generate the different variations of your power. Alright, so sometimes your power, normally when you use the bipolar, it can only be a fully high power or no power. Alright, if you want something that is in between, you can use the pulse width method. Alright, and nonetheless, when you turn a motor, you can use the method, alright, the waveform method, to actually drive your stepper motor, so that you can drive your motor like this, right? So if you connect using two coils, as I say, two coils actually provide a much larger torque than if you were to use one coil to turn your spin, your motor. So it actually depends on your conditions. If you want a large torque, normally we recommend you use two coils. Alright, two set of coils, I would say, two sets. This is the second set. Okay. Then for your stepper motor, it is straightforward method of getting precise repeatable position, because you can use your waveforms, as I say, to do. Alright, so when you code your stuff, you can code accordingly based on what you want. Alright, it's pretty, so you can code in terms of coil 1 how many pulses, coil 2 how many pulses, coil 3, coil 4 what are the periods and things like that. You can code inside your Arduino. Alright, and you can control through the sequences of your pulses, as we say. And then special integrated circuits, ICs, is available to carry out this type of details. Alright, to help you control your motor and things like that, to improvise. So the IC itself, special IC, is actually helps you to improvise your motor. Alright, so you don't need to go and self code. You can actually buy in a more convenient way, so that you save your time also. Alright, and nonetheless, you may also need to reset your sequence to fix. You need a reset sequence to actually fix your absolute position. Alright, the reset sequence is over where? It's over here. Alright, so you may need a reset sequence where the motor is driven to one end of its range detected by a separate sensor. So I would believe that sometimes your motor may be out of range, or maybe of a different position that you think, because your code is actually running like this, right? On, off, on, off. Alright, but however, in realistic case, it may be on, alright, and then it off, and then suddenly some problem has, maybe someone put his hand over on the fan or whatever. Alright, then it may actually stuck up a bit, and then stuck there, and then it goes down and things like that. So, and it may affect your positions of your fan blade or wherever. So you may require a reset sequence to actually reset the position of your motor or wherever. That's what I think lah. And therefore, this is also the purpose of me trying to do these conclusions, because I want to stress that the reset sequence is to fix your absolute position. Alright, I feel like this is like a type of exam question lah. But anyway, just take note of that lah. Alright, so see you in the next video on ADC, I think.